Hi and welcome to this on Maths prediction for the AQA Paper 3 Higher Tier Maths GCSE. Enjoy! Hi and welcome to this prediction from On Maths for the very last paper. So this is going to be filmed before any of the papers, so please bear that in mind when you watch this. The papers are very condensed, and so it's very difficult to set new videos out. But this paper is still based on all the previous exam paper questions that have come before, including the June and November ones in previous years. And we look at what comes up loads and what is long overdue coming up. Don't also forget you can do this online by clicking here, and it's completely for free, and you can sign up for free and save your scores so you can track your progress with this. On our site it's also the topic busters, which are very focused on specific topics, and there's all the Maths GCSE topics there, so you can practice a specific topic rather than the more generalised. You can also do the revisionator, which will just blast you with random questions. It normally takes about 10 to 15 minutes to complete. So if you've got less time or you want to do something regularly every night, then that's a really good idea. Don't also forget that the online version is random numbers. So the methods and questions will be the same as this video, but the answers will be different, allowing you to do multiple times. If you like this video, please click like. And if you want to see more from us, please click subscribe. Also, just bear in mind that this is a revision tool. Please do all of your normal revision as well. I hope you enjoy this video. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a liar. A liar has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a liar's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha's only got Christine left to play after we counted all the other matches. And Christine's matches have already been counted so far. So we've got the 4 matches a liar's going to play, 3 matches that William's going to play, not counting the one we've already counted from a liar, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total there are 10 different matches going to be played. Okay, factorise means put it into brackets. So looking at the first one, there's a t I can divide out of both of them. So I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. You can check your answer by expanding the bracket to check it makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorise fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w? Well, 3w. And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's 2 things that we're dividing out this time. So I'm going to have 8a on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times a by to get to a squared? Well, that's going to be a. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16a? So it's just going to leave it because the A is on the outside of the bracket. So A to A times 2 is 16A, so I don't need an A there. So for this question, we just need to remember the area of a circle. Now the area of a circle is going to be pi r squared. Now that's the area for a full circle, my dodgy circle there, but we only have a quarter of it. Now if you have a look, that length there, the 22 centimetres, is going to be the radius of a full circle if I drew the circle properly. So we know what the radius is, and all we do is we times it by the fraction of the circle we have, which is going to be a quarter. So it's going to be pi times r, which is 22 squared, times a quarter. So I'm going to do that on my calculator. Pi times 22 squared, and then you can press equals and then just divide it by 4. That's the same as timesing it by a quarter. And the answer I get is 380.1327 blah blah blah, and so to 2 decimal places that's going to be 380.13. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have 2 shoots coming from it. Now I need to find out which 2 numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44, I can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out because that will give you 88, so 2 cubed times 11 is 88. For this question, the main thing we need to remember is the triangle. Now the triangle is like the speed, distance, time triangle, but obviously this has nothing to do with speed, distance, time. The formula says that pressure equals force over area. So as long as you've got force on the top, which is measured in newtons, then you're fine, because area and pressure can be the other way around. So if we're asked to find the pressure, so we cover up pressure on the triangle, we cover that up, and it says that it's force divided by area. And it says that the force is 2280 newtons, and the area is 38. So we get our calculator out, 2280 divided by 38, and I get the answer of 60. Now the units, because force is in newtons, and because area is either in meters squared or centimetres squared normally, then the units are newtons per centimetre squared. So it's 60 newtons per centimetre squared. Don't forget, it could be meters squared, newtons per metre squared, and that's absolutely fine for pressure. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number, and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be positive 6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. Okay, so we're asked to find the length of the line AB, and the way of doing this is you work out how far across you go and how far up you go, and by doing that you create a right angle triangle. So we go 2 across here, 2 jumps across, and if you don't know that that was 2, let's just do a different method. So to get this other one, 1, 2, 3 jumps up, or you just know that it goes up to 4, down to 1, 4 take away 1 is 3. So it's a right angle triangle with sides 2 and 3, and we're looking for the third one. Now the one opposite the right angle is going to be labelled as C. These two, it doesn't matter, I'm going to call that A and that B. We use Pythagoras' formula. So A squared plus B squared equals C squared. And A is 2, so 2 squared plus 3 squared, because B is 3, equals C squared. Let's put our lines in. So it's going to be 4 plus 9 equals C squared. 13 equals C squared. Square root both sides, and let's get my calculator. So square root of 13 is 3.6055 blah 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 equals C. So to 2 decimal places it's 3.61. Now be careful, sometimes it will say that it's done on centimetre square grid, so you might have a units attached. If you want to put units but it doesn't say any, you can just write 3.61 units. Okay, so I'm asked to complete the Venn diagram, and the E at the top I like to think stands for everything. So all of those numbers need to fit somewhere in this Venn diagram. And we're going to put the square numbers on the left and the odd numbers on the right. Now there's different methods of doing this. What I like to do with this type of question is just do it one at a time. So we're going to start off with the 16. Now 16 is a square number but it's not odd. So I'm going to leave that here. 75. Now 75 is not a square number, but it is odd. So I'm going to put that there. Now 1 is a square number and it's odd, so that's going to go in the middle. 4 is a square number, but it's not odd. 28. Now 28 is not a square number and it's not odd, so that's going to go out here. 9 is a square number and it's odd, that's going to go there. 93 is not a square number but it is odd, and 2 is not a square number or odd, so that's going to go on the outside here. And I like to just add them up, find out how many numbers we've got in our Venn diagram, so 1, 2, 3, 4, 5, 6, 7, 8, and find out how many numbers we should have, 1, 2, 3, 4, 5, 6, 7, 8, so we haven't missed any, because it's quite easy with this type of question to miss a number out. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do, so either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always, and 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now, 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So on your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89, and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to the nearest penny because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to £917. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%, so that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that on a calculator. 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018. But you could do 100 plus 1.8 is 101.8 and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. And that says it's £312. And I'm going to round this to 42. I'm going to round it to the nearest penny. Okay, so that is super bank. That's how much we'd get. Now, the great bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%. And then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022, so times 1.022, and this time I get 313.34. Ooh, actually that would be 5 if I round it to the nearest penny. Okay, so it says which account will give her the most money. Well, looking at that, it's going to be the super bank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be super bank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And it says by how much. So I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny. Then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could have just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, so we've got an athlete and 2 hurdles, and if he jumps the first one, the probability of him jumping the second one will change. So it's a conditional question, and we're asked what's the probability he will hit one hurdle. Now, one hurdle does not mean 2 hurdles. One hurdle means exactly one hurdle. So you've got to be careful with the question. Okay, so we start here. And if he jumps the first one, then we're looking at him hitting the second one because he has to hit a hurdle. So we're looking at him hitting the second one. If, however, he hits the first one, he can't hit the second one, otherwise we'll end up hitting 2 hurdles, and it says it will hit 1 hurdle, so he has to jump the second one. So he's either going to hit the first one or the second one. Okay, what we need to do next is work out the probabilities he will jump the first one then hit the second one. So we just get the 2 fractions and times them together. So that would be 4/70. No need to cancel at this point. Okay, and let's work out the probability you hit the first one and then jump the second one. So that's 3/7 times 10/13. So that's going to be 30, and then I could do this in the calculator or just do it in my head, over 91. Okay, now we're either going to end up here where he's hit the second one, or here where he's hit the first one. The word or in probability means add. So he's either going to hit the second one, or, which in probability is add, hit the first one. So on the calculator, because this is a calculator question, so it'd be 4/70 plus 30/91. So that's going to be 176/455, and let the calculator do the hard work there. Now, if it's a non-calculator question, generally speaking, the denominators of the fraction are a little bit simpler, and they tend to do those on the independent ones because they can manipulate the denominators a little bit more. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Okay, so in this question we're asked to enlarge shape A by scale factor -2 with the centre of enlargement 2,5. So normally we'd first of all put the centre of enlargement on, but it's already done for us. So what I need to do now is draw my ray lines, but because it's negative we know they're going to go through the centre of enlargement. So I'm going to draw my ray line. I don't need to do the bottom right one because it will essentially be the same thing. And let's do this one. Let's try and get it as perfect as we can. So it should be something like that. Okay, now next thing to do is count how many squares we went away. So I'm going to start with the bottom left point. So we've got 1, 2, 3, 4 to get to the centre of enlargement. So if it's -2, we're going to go another 4 twice. So 1, 2, 3, 4. 1, 2, 3, 4. So we end up here. Okay. For the next one, let's do the bottom right one. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're just right on the edge there. Okay, let's do the last one. So this time I'm going to count the diagonals, and if you had a ruler you could just measure it out. So 1, 2, 3, 4 diagonals. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and now we need to connect them all up. So let's connect them all up. And probably it will say label it B, yeah. So label it B. And always check the width of A was 2 and the width of B is 4, so that's good. The height of it is 4, and so the height of B should be 8, which it is. And it looks unusual because for an enlargement you're used to it being the same way around, but for negative enlargement it basically just flips it. Right, when working with bounds, the easiest way of answering the question or thinking it through is just to do a quick number line, put the number that's been rounded in the middle, and try and figure out what the next one down is. Well, it's to the nearest 5, so the next one down is going to be 80. Now we could do the next one up, but it's asking for the lower bound, so we're only interested in the lowest possible values. Now, next thing is to work out what the cutoff point was. Why was it rounded to 85 and not 80? At what point did it need to be higher then? Well, the point at which it needs to be higher is halfway between the two, which is 82.5. So that's our lower bound for the 85. Then just repeat the process for the 160. So we've got 160 in the middle. And the next one down would have been 155. And then when we draw the line, well, it's going to be 157.5. Now, what many students would do is just look at the number. Well, the area is going to be 85 times 160, and that's what the area is going to be. But we know that the 85 could have been 82.5, and the 160 could have been 157.5. And that would give the lowest possible area. So if I get my calculator out, 82.5 times 157.5, and that gives me 12993.75. And it doesn't ask me to round it, so I'm just going to write down the exact number. Now be careful, with areas we're timesing them, so we want them both to be small, but if you were to divide them, sometimes you actually want the upper bound of one of the values, but for area you want them both to be as small as possible to give us the lower bound for the area. Okay, so we're asked to find the nth term of this sequence, so the first thing I need to do is work out what the sequence is going up in. So 9 to 22 will be 13. 22 to 41 would be 19. It's not the same. Okay, so that would be 25, and then this would be 31. Okay, so whenever you have a sequence that's not going up by the same amount, then the next step is to work out what the differences are going up in. The difference of the differences. Well, that's 6, and this one's 6, and this one's also 6. So if the difference of the differences is always the same, then you've got yourself a quadratic sequence. And the way of dealing with that is get the difference of the differences and always halve it. Okay, so we end up with 3. Now that 3 will go before an n squared. So we know our nth term will involve 3n squared, but we don't know what the rest of it is yet. So what we do is a little table, and we write in our sequence, which is 9, 22, 41, 66, and 97. And then we write down the sequence for 3n squared, which is going to be 1 squared times 3, okay, because n is 1 for the first term. So that's going to be 3. 2 squared is 4 times 3 is 12. N is 3 for the third term, so 3 squared is 9 times 3 is 27. N is 4 for the fourth term, so 4 squared 16 times 3 is going to be 48, and then 5 squared times 3 is going to be 75. Now what we want to do is take 3n squared out of our sequence. So if I call this sequence, we're going to do our sequence, and we're going to take away 3n squared from it. So basically what I'm doing is I'm going to do 9 take away 3, which is 6, 22 take away 12, which is 10, 41 take away 27, which is 14, and I'm just going to keep subtracting them. Now you might notice that we've got a linear sequence now. This linear sequence that's formed is going up in 4s. So each one is going up in 4s. And we find the nth term of this linear sequence. So we're going to have 4n, and then we're going to work out what the 0th one is. And I've not left myself very much room, and that's going to be 2. So our 0th term is going to be 2. So we know it's going to be 4n plus 2. So we put this bit here with this bit here, and that gives us our nth term of this quadratic sequence. So it's 3n squared plus 4n plus 2, and that's our answer. Now you can check this out by putting in 1 and putting in 2 and putting in 3 and seeing whether you do get 9, 22 and 41, which you will do. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule, and the other approach which I'm going to use is I'm going to work out this angle here using the sine rule, and then work out this angle here taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first, so that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it X, so it's a bit easier to write. So I'm going to use the sine rule, and that says that sine X over, so this is sine X, this is X here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8, so it's going to be sine X equals 8 sine 110 over 12, and then what I'm going to do is inverse sine both sides. Scroll down a bit more. So X is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that X is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator, and then what I'm going to do is add that to the 110 to work out what this angle here is, and I'm going to call that Y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as Y, just to make it a bit easier. So Y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that, then I'm going to type in 180 take away the answer. So that tells me that Y is 31.2104 blah blah blah. Okay, so I've worked out what Y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it. Where's A and B? A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now, if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now, that's why you must show you're working out, because if you got say 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2, and you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2. So what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done. So we can cross that off. Okay, next one, we want to do the line x equals minus 1. Okay, so where does x equal minus 1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals minus 1. Okay, so where do we not want? Well, x is going to be greater than minus 1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, now the last one, I'm going to do the line y equals x plus 2. Now, there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. And 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R. So with this, it's an algebraic fraction, but just think of it as a normal fraction first. So just think you're doing a half plus a third. How would you do it? Well, you've got to get the bottoms the same. You've got to find a common denominator. Now the way we do these when they are algebraic expressions is just multiply both of the algebraic expressions together. So with a half plus a third, the common denominator would be 6, right? So you get that by just timesing the 2 and the 3 together. Now that doesn't always get you the best common denominator to use, but it will always work. It's just sometimes the numbers get a little bit big. So we're going to do that. Now whenever you see an expression in a fraction, always just imagine or physically draw in brackets around them, and that helps us. Now the common denominator between both of those is going to be just those 2 brackets. So what I want to do is times both of the left hand side by the right hand bracket, and times the right hand side, or yeah, you know what I mean, times the right hand side by the left hand bracket. Okay, so when I do that, I've got 3 times x plus 2 at the top, and then I've got x plus 5, x plus 2, plus 9 times x plus 5 over x. And I'll write x plus 5 first, just so it looks the same. Okay, now we can just add the tops now. So I can just add the tops together, and the bottom is the same, so I'll just write it once. Now I'm going to expand the brackets at the top, so 3x plus 6 plus 9x plus 45. Okay, now I need to collect the like terms at the top, and I'm just going to put this into my answer box. Now it might need it expanded, so I'm going to expand the bottom as well. So the bottom will be x squared plus 7x plus 10. If you don't know how to do that, see our video on expanding quadratics, or expanding quadratic equations, or expanding quadratic brackets. And let's collect the like terms at the top. So 3x plus 9x is 12x, and then 6 plus 45 is 51. And that's my final answer. Now in the exam, it doesn't always need you to expand. I could have left the bottom with brackets around it, unless it explicitly tells you to. So I think on the website for this question, it asks you to expand all the brackets. So if the question asks you to, you do have to. This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. And we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite, so we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try. And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5, and that gets me 1.81712 blah blah blah. Okay, now I need to keep that answer, so what I'm going to do is I'm going to press the cube root button, Then I'm going to click inside the root, I'm going to click answer plus 5. And the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers. And it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5. And we've got 1.9034, blah, blah, blah. Cube root button, answer plus 5. And we've got 1.9040, blah, blah, blah. Now, we're looking for 3 decimal places, so the numbers we're looking for being the same is these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041, blah, blah, blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something, okay? Now, we've got 2x squared, and so minus something x. We've got 2x squared minus 28x. So we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here, so it's going to be 7 squared. Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it, that's completing the square, okay? So I'm going to replace that with what I've just found out that it is, x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102. There are a few different methods to answer this question, but I prefer the method where we just replace f of x with y because it becomes a lot easier. So I'm just going to write out the same equation. Now, when you want to find the inverse, which this is, of the function, all you do is swap the y and the x around. So we're going to have x equals 4y minus 10 over 7. And then all we need to do is get it so we've got y equals. So the first thing I'm going to do is times both sides by 7 to get rid of the fraction. So we've got 7x equals 4y minus 10. Then I'm going to add 10 both sides. So we've got 7x plus 10 equals 4y. And then I'm going to divide both sides by 4. So I've got 7x plus 10, all of that over 4, equals y. Now, it's not y really, it's f, inverse of a function. X equals 7x plus 10 over 4. And the 7x and the plus 10 can be either way around. So 7x plus 10 over 4. This question might just ask you to rationalise the denominator. It might ask this question in the form that it's in, or it might ask you to show that that fraction is the same as another one, where you'll get marks for the working out. So to do this one, what rationalising means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalising means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, a positive times a negative is a negative. And any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now, the 3 doesn't go into 25, so we can't cancel it any further. So it's going to be 25 for A. B is the coefficient of the root, so it's going to be 3. and the bottom number is 58. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimetres at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry. Now, the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that. So that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angle triangle here, we have two of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimetres and 5 centimetres, and all of them in centimetres, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras. So we're going to square them, add them, and then square root it. And we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61, and we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Whoops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11. And we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it X, equals opposite over adjacent. Tan X equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that X is 54.62438 blah blah blah. It says it wants its 2 decimal places. So the answer I'm going to write is 54.62. Okay, so we've got a cubic graph here because it goes down and up and then down again. And we're asked to find the equation of the graph. Now, the problem with this is the normal method is to put down 3 brackets, and any solution it gives us in the graph, we write down the opposite, the inverse sign, right? So for this one here, it would be x minus 6, because 6 take away 6 is 0, therefore that's a solution. And for this one here, it would be plus 7, because 7 take away 7 is a solution, right? Because it equals 0. But the problem we have here is we've kind of run out of solutions. and therefore the natural thing is to think, well, maybe it's a quadratic. But we can see it's not a quadratic, it is a cubic, so it needs to have 3 brackets. And not all cubics make 3 brackets, but this question will. So we've got to think, well, hang on, we actually have 2 solutions here. We've got the down solution and we've got the up solution. So that actually represents 2 solutions, not 1. And if you have a look at here, we've just got 1 solution because it just goes through once. So when it turns on the axis, it gives us 2 solutions. So there are 2 lots of x plus 7. So a bit of a unique situation, that, but it's useful to remember.
I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.